Okay, good morning, happy Friday, welcome back. Today is April the 4th. We do more about factoring and then products of binomials, like some special theorem that we're going to learn. And then coming up Monday is our third quest. We have 5 altogether. This is quest number 3. Again, quest number 3 only goes up to class 23, which doesn't count any of the stuff we just did with factoring, right? So the quest is really just about the exponents and the radicals. Questions on the calendar? All right, so again, this is a full period quest, so get here bright and early, ready to go first thing on Monday. We can actually start folks a little bit earlier, so if you want some extra time, maybe 8:30. What did we do last time? Anybody remember? Yeah, we did, but last one was a test, though. It was 8:15, but it was a test, wasn't it? Yeah, and I think this is a little bit shorter, so let's start at 8:30. If people want 10 extra minutes, just get here for an 8:30 start, and that's coming up on Monday. Questions? Okay, so we're jumping in here on page 38, which is actually towards the end of today's lesson. I decided to do this one little thing in the beginning, and then we'll go back to the start of the lesson I had planned. So towards the bottom of page 38, number 12 says, let's look at some special factors and see why we call them special. So we're just going to do 3 quick examples here, multiplying together two binomials. But turns out they're special. X plus 3 times x minus 3. So we're going to, I'll just do the lobster claw thing here, right? So the x comes in and hits everybody. The 3 comes in and hits everybody. And let's just go ahead and start multiplying and combining. So x times x, x squared. And then the next part is a minus 3x for me. And then the next part is a plus 3x there in the middle. And then the final part is a minus 9. And then it's very common for these ones for us to combine 2 terms in the middle, but what's uncommon is what happens here. What happens here is they completely cancel. Normally they just smush together and become a single x term in there. But here the minus 3x and the plus 3x go away. So that means that the answer is just x squared minus 9, which is pretty unusual. I'm just going to write up here something, you don't have to copy this, but normally we'd have something like x squared plus 2x minus 7. That's usually what we get when we multiply 2 things, right? You'll have an x squared, then you'll have an x, then you'll have just a number without any x. But in this case, the x term in the middle went away. Let's try this next one down here. So again, I'll lobster claw. So multiplying here, 7 times 7 is 49. And then the next one is a plus 7y, and then in the middle, minus 7y, and then at the end, it will, let's multiply these last ones together. It's y squared. Is it plus or minus? Minus, right? Look at that. And again, 2 terms in the middle completely cancel. And so this one is just 49 minus y squared. So how do you want it to be rewritten? What do folks think? Are these 2 things equal? Victor says yes. Who says yes? Erica says yes. Yep, they're equal. The 49 was positive in both cases. The y squared had a negative in front of it in both cases. They are equal. Why do you like that way better, Megan? Like with the variable squared in the front, and then, yeah. So totally fine. Either way is okay. Let's do the last one. So again, lobster claw. This one we got to be a little bit more careful because there are numbers touching the variables. So when I multiply the first terms together, what do I get? 2x times 2x is 4x squared. And then I'll do the ones on the ends, the outer ones. Minus 10 xy, that's right. And then we'll do the ones in the middle, the inner terms. What is that? Plus 10xy. And then finally the last terms, the ones on the end. Minus 25 y squared. And now we're not at all surprised because we've done this twice already, but these middle terms magically cancel each other. So we just get 4x squared minus 25 y squared. Okay, so what we're going to do is start to recognize when we have this kind of cancellation. It leads to this formula down at the bottom. The point is with all these guys in parentheses, the two things in the parentheses were exactly the same except for what? Sign. 7 minus y, 7 plus y. X plus 3, x minus 3. 2x plus 5y, 2x minus 5y. So I'm saying exactly the same thing twice, but one is a plus and one is a minus. And whenever we have that is exactly when we get that cancellation. So here's the formula down at the bottom. Put some stars around it. If you are multiplying a plus b times a minus b, which is the pattern that we established up here, then you just get a squared minus b squared. The first guys multiply, the last guys multiply, and that's got a minus in front of it. And then the inner and outer terms completely cancel. So a squared minus b squared is what we get. Okay, so why am I telling you this? If I wanted you to multiply these, you don't need a magic formula. You just multiply them and you'll see, and maybe you'll be surprised and maybe not, but you'll see that they cancel in the middle and you'll get it right. But I'm telling you this not because I want you to know how to multiply a tiny bit faster, like 1 second faster than normal. I'm telling you this because I need you to be able to take something like that and factor and go the other way. Multiplying is the easy way, but factoring is the hard way. And we need this formula in order to factor some things. So on the next page, there's a little acronym that I introduce here. This is called the difference of two squares because it's a square minus another square, difference of two squares, which I abbreviate DOTS, D-O-T-S, difference of two squares. So on the next page, first example, x squared minus 64. X squared minus 64. So let's factor. We'll start with two parentheses. So first I need the things in the beginning that are going to give me x squared, but they have to be the same. So that's going to be x and x. And then I see 64 and I say, oh, that's a perfect square. What's going to give me 64? 8 and 8. And finally, what about the signs? 1 plus, 1 minus, either order. And that's it. So we have just factored x squared minus 64. And I also want to say this. Last class, we did a lot of factoring of stuff that looked like that. And we'll do one of these again at the start of today, but it involved the product of two numbers and the sum of two numbers, right? Yes. That's kind of out the window here for this x squared minus 64. I mean, I guess it still works, but I don't think of this as being a product and a sum. This for me is just a special formula, and as soon as I see some perfect square minus some other perfect square, it's this formula. So it's the same thing in the next row. 100 minus a squared plus b squared. 100 is a perfect square. It's not a coincidence. A squared b squared is a perfect square. So as soon as we see that, it's pretty easy to just fill in the blanks. What's going to get me that 100? 10 and 10. What's going to give me a squared b squared? Yeah. So what's wrong with writing this? Will that give me a squared b squared when I multiply? Yeah, if you multiply those, you'll get a squared b squared. But these two guys are not going to be the same thing except for the signs, which means it's not going to cancel in the middle. So that thing that led to cancellation was that the two parentheses have to be identical except 1 plus and 1 minus. So you can't just get a squared b squared any old way. You have to get it by putting two copies of the same thing. So what's the same thing that I can put in both to get a squared b squared? Is ab. Make sense? You can't just put anything there. You got to put the same thing in both. That's how we get that cancellation. And then again, the signs, 1 plus, 1 minus, either order. Okay, let's look at this one. X to the 4th minus 16. Okay, it is a perfect square minus a perfect square. What two identical things will give me x to the 4th? X squared and x squared, right? Because we know we add those powers when we multiply them together. What two things are going to give me 16? 4 and 4. Don't put 8 and 2. You got to put two copies of the same thing. And then again, 1 plus, 1 minus. Turns out this one isn't done. It's correct so far, but it's not factored completely. I'm going to copy the x squared plus 4. Then I'm going to say this guy here that's highlighted is a difference of two squares just on its own, right? It's something squared minus something squared. So what two things are going to give me x squared? X and x. What two things are going to give me that 4? 2 and 2. And the signs? Plus and minus. That's it. Ooh. Yeah, why can't we do that to the first one? X squared plus 4. So if it were going to be something like the same pattern, then to get x squared, I guess it's x and x, right? And to get 4, 2 and 2, what about the signs? Both positive, right? Because I'm trying to get a positive 4. But if they're both positive, then when I lobster claw and I do this guy, that's a plus 2x. And when I lobster claw and do this guy, that's also a plus 2x. And they don't cancel. They just add up and give you 4x. So the only way that you're going to get something which will cancel is if it was a minus in here, because that allows you to put one sign of each. So I'm asking you to start recognizing the pattern of the difference of two squares, but I'm also asking you to recognize that the sum of two squares you cannot do anything with. They're really different. One little sign makes all the difference, which actually gives us our answer to the next one. X squared plus 9. Can we factor it? No. So we'll just say prime or not factorable. Okay, and then there's one more down here at the bottom. Let's skip that one for now. Questions on the difference of two squares formulas? Okay, so that's that topic. But the main topic for today is the one that starts at the beginning of this lesson, which is on page 35. So let's go back a few pages to page 35. Okay, and let's start with Lauren, number 1. Okay, let's try number 2, Victor. Times 2x minus 5. Oh, it's hard to read out loud. You could say the quantity 3x plus 2 times the quantity 2x minus 5. Okay, so I'm going to highlight our two numbers. Remember, we would always focus on those two numbers, and we would think about product and we would think about sum. So let's just multiply those two numbers and write our answer. So the product of those two numbers is negative 10, yes? And the sum of those two numbers, negative 3. So maybe, just maybe, the answer to the question, what do you get when you multiply these two together is, so let's just see if we can remember the basic format. So it was x squared for every one that we did last time. And then there was a certain number of x's and then a certain number at the end. Where did the product go? Did the product go in the middle or at the end? It was at the end, right? The product was the last thing. So I guess we're saying that -10 is the last thing. And then the sum, remember it was the product here and the sum was this number touching the x. So the sum of -3, I guess, goes right there. So if what we did last time still holds, then when I multiply this whole thing times this whole thing, meaning, lobster claw, all that jazz, I guess we're going to get x squared minus 3x minus 10 because the product sum, that's where they went. Okay, so let's actually try to multiply these two guys together. So again, lobster clawing here. And so when I multiply the first things together, 3x times 2x is 6x squared. All right, I'm already disturbed because that wasn't what I wrote down based on everything we did last time. Everyone we had before was x squared, but all of a sudden this is 6x squared. Okay, when we do the outer terms, positive 15 or negative 15? Okay, so that's negative 15x, no problem. And then the inner terms, positive or negative 4? Positive 4x, okay, that's fine. And then the last terms, negative 10. And so now we'll mush together the two terms in the middle, just like we always do. So I'll copy the 6x squared. How many x's do I have when I smush these two together? Positive or negative? Negative 11x. And then there's a minus 10. Okay, so there's all kinds of bad news here. Well, the good news is the answer that we thought we were going to get at least had one part right. Which part was correct? It was the product. The negative 10 is exactly where we expected it to be. And that makes sense, right? Because we multiply 2 times negative 5 when we're doing the lobster claw, and that's just the product of those two numbers. But everything else is wrong. I guess I can understand that it shouldn't be x squared. Why was it a 6 here? Where'd that 6 come from? Because the 3 and the 2 in the front, right? That 3 and that 2, it's going to give me a 6. Okay, that's not too hard to believe. But look, negative 11. When I added the two numbers, the highlighted numbers, I got negative 3. Where did this negative 11 come from? And if you really think about it, you see how complicated it is. Why was it negative 11? Well, because we did the 3 times negative 5. That was negative 15. And then we did the 2 times 2. And that gave us the 4. So it wasn't just enough to look at the 2 and the negative 5, but we had to take that 2 and multiply it by another 2. And we had to take that negative 5 and multiply it by 3. So we got 4 numbers all working together here. And then finally you combine those two middle terms and you get negative 11x, which has like no traces of any evidence of where it came from. That negative 11 is quite mysterious. Like it's easy enough to multiply, but can you imagine, how would we know what this thing came from? If I gave you this and I said factor it so it looks like this, how? Like that negative 11, it's so complicated to get there. So you won't be surprised to know that factoring these kinds of things is much more complicated than the product sum ones that we did last time. Okay, so let's answer this question. It says now factor this thing right here, 6x squared minus 11x minus 10. Normally this would be a very hard question, and all of today is about figuring out how to answer that. But at the moment, based on what we just did, this is an easy question. Can you guys write the answer? Remember, factor means write as a product. So start with 2 parentheses. And then if you just look around on this page, you will find the answer. (3x plus 2 times 2x minus 5). Everybody see where that came from? We just multiplied those two things and got this, which fortunately for you is exactly the thing I just asked you to factor. So only because we've got a good short-term memory and it's answers on this page is it easy to get the answer. But if we didn't have the answer on the page, it would be really hard. So that's what we're trying to develop today, is how do we get that answer? But that's the kind of goal, is to take something like that, 6x squared minus blah, blah, write it as a product of two binomials. Okay, so as we've just seen, factoring this thing involved first terms. I'll circle these guys in purple. So the first terms, whose product was what? What do I get when I multiply those? 6x squared. Okay, no worries. I guess I can see that right there. So we need two things that multiply together and give 6x squared. Those are the first terms. And whose last terms, I'll do these ones in red, are a product of what? Negative 10. No problem there either. I can see the negative 10 clearly in the original problem. So when I give you 6x squared minus 11x minus 10, and I say factor, you have a way to get started. You're looking for two things in the front. I've circled them in purple, but pretend we don't know what they are, that multiply to 6x squared. Okay, there's not that many possibilities. What two things multiply to 6x squared? 6x and 1x. And what's the other thing? 2x and 3x. There's only two things that can multiply to that 6x squared, all right? And then you want two other numbers. I've boxed them in red, but you pretend you don't know what they are. But you know their product has to be negative 10. Okay, there's a few possibilities here. Give me two numbers that multiply to negative 10. 1 and negative 10. 2 and negative 5. 5 and negative 2, which is different from 2 and negative 5. First one we said was 1 and negative 10. Negative 1 and positive 10, which is different from that first one. So there are four possibilities for numbers multiplying to negative 10. And there were two possibilities for numbers multiplying to the 6x squared. And you could imagine that you got to try like a lot of different combinations, right? Every one of these things that gives you the 6 with every one of the things that gives you the minus 10. Turns out there are 16 possibilities, which I've listed for you here. And let's just pick one at random here in the middle. Here, we'll look at this one and we'll look at this guy. Just picking two of them. What do you get when you multiply the first things together? 6x squared. What do you get when you multiply the last things together? Minus 10, which is exactly the two things we were working on, right? Get a 6x squared, get a minus 10. Same game over here when you multiply the first things. 6x squared. When you multiply the last things, you get negative 10. But what's going to be different for each of these is what you get in the middle. And coming up with this list is a lot of work. That's why I typed it up for you, so we wouldn't have to sit here copying this long list of 16 things. But really, take a look at it. The first two rows all involve 6x and 1x. See that? The last two rows all involve 3x and 2x. So that's how they're separated in rows. And then if we look at the first entry, it's a positive 1 and then a negative 10. The next one is a negative 10 and a positive 1. Isn't that the same? Aren't those the same numbers? Positive 1 and negative 10? Just swapped? They're the same numbers. Why is it going to give us different things? Because what? I think what did you say? They apply to different things? I think that's a good way to say it. When you do the outer terms here, the 6x goes with the minus 10, right? So we're going to multiply those and get negative 60x. But when you do the outer ones here, what is the 6x going with? Just the 1. You're not going to get 60x. You just get 6x. Do we see that they're different? Even though it's the same numbers, plus 1 and minus 10, swapping them changes what they apply to, which means you're going to change what you get for the outers and the inners. So you really do have to list both of them because they're different. All right, so these are the two with a plus 1 and a minus 10, but just as well it could have been a minus 1 and a plus 10, different numbers. Now the same numbers here, but reversed, which changes the problem. Those were the 1s and 10s, but sorry, yeah, the 1s and 10s, but we could also do 2s and 5s, which is in this next row, plus 5 minus 2, or swap them, minus 2 plus 5, or change the signs on these guys. So instead of a plus 5, make it a minus 5. That's what I've got here. minus 5 plus 2, plus 2 minus 5. Yeah, same 4 sets of numbers. You got to change the order and you got to change the signs. And those are all the ones with 6x and x, but just as well you could do the same thing with 3x and 2x. You don't want to do this, right? I mean, like, this is not a process that you want to get involved in, right? You'd have to come up with every possibility, and then you'd foil them all together or lobster claw them all together, and you'd cross your fingers that you would find the one where the outers and inners give you exactly what? That minus 11x. All of them give you 6x squared and minus 10. The only difference is what's going to come out in the middle. You're crossing your fingers that you stumble on the one with the minus 11x in the middle, which is a whole heck of a lot of foiling or lobster clawing or box methoding. Just for the record, where's the answer to this one? I've got my list of 16. We know the answer is this, 3x plus 2 and 2x minus 5. It's the last one. So if you happen to write things in this order, then you would have done 16 different foilings, and eventually on the last one, you would have gotten the minus 11x in the middle. Say hooray. Okay, so I put the list in this order, so maybe I put it so the last one was the one that was going to work. But still, it's a lot of work to come up with the list, a lot of work to foil, and there's a better way. So I'm showing you the list just to convince you there's a better way. Okay, so we're going to do this thing called the box method. That's the better way, but we need one more fact. This is here in number 6. So we're going to multiply this thing out, which is just a completely different set of binomials. We're using the box method just so that we can make an observation. So I know that normally I lobster claw, and I know some of you guys really like foil, but I just want to do the box method because it's going to help us. So up on the top, I'll put the 5x and then the minus 2, and then on the side, 3x and plus 1. Okay, and then we remember how this works, right? In this top left box right here, what do we put? How do we figure out what goes there? Yeah, we multiply the first row in the first column. 15x squared goes there. Just take a moment, fill in the other 3 boxes. You just have to multiply the right things. The right row entry and the right column entry. Okay, top right, what do we get? Negative 6x, bottom left, 5x, bottom right, negative 2. Any questions on how to fill in the box? Okay. We're going to make this observation about the diagonals, but I want to make one more observation first. Can you tell me, if you just look at the, I'll highlight here, if you look at the 15 and the 6, what's the biggest number that goes into both? 3 goes into both, right? And do you see that there's a 3 right there? In fact, the reason 3 is in both of them is because there's a 3 that's literally in both of them, right? Like to get that first row, you multiplied 3x by some stuff at the top. So of course there's a 3 in both. Okay, and then what else is the same in both? Let's highlight this guy, x squared and x. I want to take out as many x's as I can, but you can only take out what you have. So what's the smallest number of x's that are in both? It's just the 1. There's a single x that's in both. The first term has x squared as an extra x, but the second term only has a single x. And do you see that there is a single x sitting here in the front? That single x is why there's an x in both, because you multiplied x times some stuff to get those. And let's go down to the bottom row. What number goes into both of these? The biggest number is 1. Right? There's no bigger number than 1. There it is. It's 1. Are there x's in both of these terms here and here? No, there's a single x in the 1, but there aren't x's in both. So clearly there wasn't an x down here, because if there was an x down there, you'd see x's in both. Do we buy that? So we're going to be doing this thing called factoring out the greatest common factor or greatest common divisor, and that's That's kind of what we're talking about here. We're making these observations here. Let's play the same game in the first column. So looking at this entire thing and this entire thing, I want to know, can you tell me what's up here without knowing that it's 5x? I want you to be able to see that there must have been a 5x at the top. What's the biggest number that goes into 15 and 5? It's 5. You all see that? And are there any x's in both? Yes, there's at least a single x in both, right? And that single x is there because of this x right here and the 5 you guys just talked about. Let's do the same thing in the last column now. So here and here, what's the biggest number that goes into both? 2. Are there x's in both? No, so it's just got to be 2. Was 2 the thing that was sitting at the top? Not quite. What was sitting at the top? It was a -2. Okay, we'll talk about the detail of how you know whether it should be positive or negative in a few minutes. But at least we see the 2 and not a 2x. Okay, so the observation that I wanted to make about the diagonals is the following. Can you guys do this? Multiply these two together and multiply these two together, completely separate. Just multiply those two things together. So 15x squared times -2 and -6x times 5x. What do we get on the first one? -30x squared. Second one? Same. Which is not a coincidence. It might be a surprise, but it's not a coincidence. Turns out it's always true. When you multiply two binomials, like we had right over here, using the box method, the product of the two diagonals will be exactly the same. And if you want to see why, see me after class. I can show you why. It's very quick and easy, but I don't want to take our time right now doing it. But the product of the diagonals, always the same. We're going to use that. Okay, next page, and we will start our very challenging example, trying to factor this thing right here. 6x squared minus 11x minus 10. Again, you already know the answer. This is the one that we did on the first page. What's the answer? 3x. Yeah, right. But the goal is to get that answer without the miracle of having it right in front of us on the page. So that's what we're going to do right now. Okay, so the left-hand side are the instructions. Right-hand side is some of the procedure written out. We're going to fill in a little bit ourselves. But this is largely the example problem, and then we'll do some full-fledged on the next page. So first step is to draw a rectangle with 4 smaller rectangles. It's there. Next step is to put the first term into the top left rectangle. So right up here, 6x squared. First term goes in the top left. So this is something that's going to be new to many of us, is this process. C, put the last term into the bottom right rectangle, minus 10. Okay, moving on to D, it says multiply the two terms on the diagonal. Now, there's actually 2 different diagonals, but one of them is completely blank right now, so there's nothing there. But we're going to multiply the 2 things that we just wrote. So 6x squared times -10 is -60x squared. So that's what goes right here. -60x squared. Everybody okay with that? Let's multiply the 2 things on that diagonal. Okay, part E is the long and complicated step. It says list all the factors of the product you just wrote, the -60x squared, where each factor has an x in it. So for example, I'm going to write something that you never get to write. One way to get -60x squared is something like -30x squared times 2. You buy that? Because I put both x's in the front here. So that works, doesn't it? It gives you -60x squared. But what I'm saying here is that each term has to have a single x in it. You don't get to put both x's in one and then leave the other guy out in the cold. So each term has to have an x in it. So this is no good But for example, negative 30x times what? 2x. That's okay. So that's what we're talking about. Each term has an x in it. It also says, be sure to account for the sign of your product. And then there's this little shortcut. It says, technically, you don't need to list them all. You can stop once you found the winner. And I haven't told you how to find the winner yet, but just to be complete, I've got them all listed over here. And there's a bunch. And you can see why this might be the long, kind of complicated step. So we're looking for all the ways to get negative 60x squared. Well, there's a process. How many times does 1 go into negative 60? Negative 60. How many times does 2 go into negative 60? Negative 30. How many times does 3 go in? Negative 20. 4 goes in negative 15. 5 goes in negative 12. 6 goes in negative 10. Does 7 go into 60? Nope. 8 into 60. 9 into 60. 10 into 60. How many times does 10 go into 60? Is negative 6, and that's where we start kind of on the other side. 10 and negative 6, not 11. 12 goes in negative 5, and you list them all. Or you could recognize that essentially we're done when we get here, and then you just copy but change the signs. So there we go, 12 different possibilities. So here's the key. Once you've got them all together, part F. Circle the factors that add up to the middle term in the original. Let's go back up. There's one number in that original thing that we haven't used yet. What is it? Is that negative 11, right? We started with 6x squared and minus 10, but we haven't thought about the negative 11. Here's the one spot it comes in. You're looking for two numbers in this long list of factors that add up, sum, to negative 11x. So, for example, if you add up these two terms, negative 59x. If you add up these two, negative 28x. Getting closer. The goal is negative 11. Can you, so that's negative 17x. This one, negative 11x. That's our winner. Negative 7x is too far. I'll just do one over here. The sums on the second column are the same, just they're all going to be positive in this case. So like I said, you don't need to list them all. In fact, you don't need to list any, as long as you can find the one that adds up to that middle guy, which is negative 11x in this case. Okay, so I don't know how I ended up doing this, but there's a step missing here, and the fact that I go from F to H means I assume I had it and then somehow accidentally deleted it when I had my Word document open. So let's add in the step that I deleted. It's pretty easy. Put the winning factors into the empty rectangles. Put the winning factors into the empty rectangles. Good news is it doesn't make any difference which order you put them in. So I'm not going to fill this, well, I guess you can fill it in if you want, but so the winners were 4x and minus 15x. So you could put 4x there and minus 15x there, or surprisingly, you could put them in the other boxes. It makes no difference. Right, yeah, multiplying two things, the order doesn't matter, and makes no difference where we put these two guys. So I put them there. I've actually already got that typed in down here. Well, let's actually not look at the typed in thing. Let's go back up to this one that we filled in. Everybody have this filled in with the blue? Negative 15x and 4x, those are the winners. Okay, and then we're just about done. What we have to do now is figure out what were the things that were over here that when we multiplied, you know, down and across, gave us the guys in the middle. And the idea here is what we said on the last page at the bottom. Looking at, I'll highlight, this 6 and this negative 15, what's the biggest number that goes into both? It's 3, right? 3 goes into both. Well, the only way 3 goes into both is if there was a 3 right over here off on the side. So let's start that with a 3. So we highlight there, and we know definitely there's a 3 here. Now let's look at the x's. You want to take out the least number of x's you see. What's the least number of x's I just highlighted? It's just a single x. And the only reason there's a single x in both is because there must have been a single x right next to that 3. So there's your 3x. Victor. Good question. We'll talk about the negatives. There's going to be one negative we got to put in here, and I'll tell you where it comes up. Okay, let's look in the bottom row. Highlighting again. 4, -10. What's the biggest number in both? 2. 2 goes into both. So in this red circle to the left, definitely there's a 2. I'm going to, I'll just call it a 2. Okay, and again, looking down here, is there an x in both? No, so it was just plain 2 down there. Let's look in the first column, highlighting. Biggest number in both? 2, right? 2 goes into both of those guys. So there's definitely a 2 up in the top here. And again, you want to pull out the least number of x's you can find. There's one x that's in both. And the reason there's an x in both is that there must have been an x at the top. So this up here is a 2x. And then finally, this guy and this guy. Biggest number that goes into both is 5. So we'll put a 5 up here at the top. And then we'll handle this positive negative business. Any questions on getting those 4 circled things? Okay, so let's come down here. Victor, can you read H, please? Okay, that's the key right there. The sign of the first entry decides whether you are positive or negative. So coming back up here, looking at this first row, the first entry is the 6x squared. Was that positive or negative? That's a positive 6x squared. So you don't need it, but I'm going to put in I'm going to put pluses and minuses on each of our 4 numbers. Look in the second row, but the first entry dictates whether it's positive or negative. Is that 4x positive or negative? Positive. So that 2, also positive. Now look at the first column. Look at the first entry. Positive or negative? Positive 6. So up there, positive 2x. Finally, last row, last column. First entry is negative 15x. Negative 5 is what we need to put in the front here. This negative 10 does not enter into the calculation at all. It's just the first thing in the row or the column. Megan. Yes. We would get the same answer if, yeah, so remember, it didn't make any difference where we put these guys. But it seems like it would change, you know, like then this would become a -2. But actually that number 2 wouldn't be a 2 anymore. As soon as you brought this negative 15 here, what's the biggest thing that goes into the new negative 15 and that negative 10 is the 5. And so actually what would happen is these 2 guys would just swap and these 2 guys would swap. And so you just end up writing the same thing, but swapped. Okay, I think we're ready for the answer. Can somebody read the answer from the previous page? 2 parentheses. Ryan, what was the, do you have the answer there? It's this guy right here. 3x. Yeah. 2x minus 5. This was the answer because I gave you the answer on the previous page. But do you see how to get the answer from the table? How to read the answer off of the table? It's staring at you. 3x plus 2. It's over here. And then at the top, positive 2x, negative 5 just becomes 2x minus 5. Okay, so that's it. And I will say that you have just witnessed, maybe the toughest calculation I'll ask you to do all semester, toughest process. I understand this is a difficult procedure, at least at first glance. But like anything, with practice it gets easier. So let's start practicing. Oh, no, there's no easy way to get to the winner, which was what, this guy here. Some people can just see it. And remember, I used the word miracle last time. Some people can just see the magic numbers that are going to give you the right product and the right sum. Ask one of them. I'm not one of them. I have to list a lot of stuff before I find the winner. Okay, let's go to the next page. Here it is, 3x squared plus 16x plus 5. First thing to recognize is what makes this guy harder than the product sum we did last class. There's one thing in that problem that says this is the hard kind, not the easy product sum. It's the 3. It's that 3 right in front of the x squared. If it was just plain old x squared, forget all the box stuff. It's just product sum. You guys did quite well on the homework with that last class. So the first thing to recognize is, when do you have to do this crazy process? It's when it's anything other than just x squared. So we start with a box. And then we begin filling in what's in the top left of the box. One of those things from the original. 3x squared goes right up here in the top left. Something else goes in the bottom right. It's 5. And the next thing we did was find the product of that diagonal. So I'll just write the word product here. 3x squared times 5 is 15x squared. Okay. Then we come to the hard part, which is to list all the factors of 15x squared. Good news is there's not as many here as there were on the previous problem. So 2 things that multiply to 15x squared. Really, you're just thinking of what multiplies to 15 and then tack an x onto each one. So how do we get a 15? Is 1 and 15. But what am I going to put on each of them? X. What's the other way to get to 15? So that's the same as this, so we don't need to write the same in the other order. But 2 other numbers that multiply to 15 is 3 and 5. And again, what am I missing? X on both. Really, that's it. Those are the 2 ways to get 15x squared, kind of. You can get 15x squared by multiplying all positive things, like here. What's the other way? Is multiplying all negative things. So just as well, you don't need to write this. I mean, look at the original. It's all pluses, so it's definitely going to be all pluses in here. But if you want to be complete, then -1 and -15 will still give you positive 15 when you multiply. And also -3 and -5 will give you positive 15. I mean, only one of these 4 things is the right answer. So what was the key here? There's something we didn't use yet in the original. What didn't we use in the original yet? Is that 16x? And this is the part where we find the sum of all of our factors. So when you do 1x plus 15x, 16x right off the bat. That's the winner. I'll just fill in the other ones so that we can see it's the only winner. Adding up the next row, 3x and 5x is 8x. Next row, -16x. Last row, -8x, just adding straight across. Okay. So if you start to get good at this process and you want a little shortcut, a way to save some time, you don't need to make the complete list of factors. Just write down one set of factors and then just add them up. And if you get lucky and that's the winner, then stop. But if not, then list another set of factors and add them up. Okay, so we're grabbing the winner here, which is these guys. What do I do with, oh yeah, Ryan? We're adding these guys. So 1x plus 15x. No, it's not. Yeah, if we have this 16x, I think 1 apple plus 16 apples is 15. It doesn't become apple squared, it's just counting apples. Okay, what do we do with these circled guys here? 1x and 15x. Put them in that diagonal. Now, it doesn't matter where you put them, but let's all put them in the same spot. So can you guys just copy where I'm putting them? It makes no difference, but I'm just wanting us to be uniform and so we can all have the same looking thing here at the end. Okay. And the last tricky part is to look in each row and column and pull out the biggest thing you can. First row, what number goes into 3 and 1? Biggest number you can find is just 1, right? So I'll put a 1, you don't need to put it. Are there x's in both? Yes, so there must have been an x out here. Second row, biggest number that goes into 15 and 5? It's 5. Are there x's in both? Nope, so it's just 5. First column, what number goes into 3 and 15? 3. Are there x's in both? Yeah, there must have been an x up here at the top. Second column, biggest number that goes into 1 and 5? Just 1. Are there x's in both? No, so it's just 1. The last piece here is the signs. The fact is everything in the boxes here is positive, so it's all going to be positive in the front here. So I guess I'll just put some positive signs here in the middle so we can know. And then we'll write our answer. So we just have to write the stuff that's now outside of the box in the parentheses. So first thing on the top, just read it off, 3x plus 1. Second thing on the outside, what do I write? This is here on the left, x plus 5. That's it. Okay, so what's that? It's a lot of work. It's a lot of work. All right, so this was the first time you guys actually did one starting from scratch, and hopefully it was a little bit easier than the first time we just looked at the one that was on the previous page. Let's try another one. We're skipping number 9, but number 9 basically says, look at this guy. Is this one of the hard ones from today or one of the easier ones from last class? Easier because it's a 1x squared. But if you feel like using the box, like if you just want to practice with the box, or if you just get confident and feel comfortable with the box, turns out you can ignore all the product sum stuff we did last time and just use the box on all of them. So you can use the box even on what I'm calling the easier ones, right? So if you just say, I want to do every one of these the same, whether it's easier or harder, you can use the box, right? Let's come down here. Let's try something with some negatives. How about part C? Let's try part C. Okay, so starting with the box. Yeah, this one's going to be tougher because the numbers get pretty big. Okay, what do we have here? Top left, 18x squared. Bottom right, -6. All right, so we fill those in, that's pretty easy. What do we have to calculate next? we have to find the product of that diagonal. So let's find the product. Negative 108x squared. Is that okay? All right. Next thing we need to do is list the factors. Factors of negative 108. That number could be a little bit intimidating. It's certainly not as small as most of the ones that we usually factor. So if you have a calculator handy, take it out. We'll use it for this one. Let's start with, I'll start with 1. This one should be pretty easy. How many times does 1 go into negative 108? Negative 108. What am I missing on both? X. I'm going to put them in a second. I'm just going to focus on the numbers, and then I'll put all the X's back. Okay, 1 goes in. How about the number 2? Does 2 go in? Negative 54. Okay, turns out 3 goes in, and this is the part where you might start using your calculator if you don't like doing this kind of arithmetic thing by hand. But we can just do, 108 divided by 3, and we get 36. So what's my answer here? Negative 36. Okay, and the next one is 4. And so we do 108 divided by 4. Oh, look, it goes in. 27, so what am I putting? Negative 27. Okay, and then does 5 go into 108? Does 5 go in? No. But even if you really were like have no confidence in your ability to do arithmetic, you can just do 5 and say, oh, it's a decimal. Didn't work. Does 6 go in? I don't know. Do you guys know? 6. Oh, 6 goes in 18 times. It's not that bad with the calculator, right? I mean, like you can zip through these pretty quickly. So this is 6 and negative 18. Now I'm going to stop there. Not because we finished with the factors, but because we don't need all the factors. We just need enough so that we get the winner. So how about we just see if we already have the winner in front of us? And if not, we'll keep going with this process. What do we do with all these factors? We add them. All right, so this is the part where I said I'd put all these x's back. So let's get those x's everywhere. And then we're doing the sum. So 1x plus negative 108x is negative 107x. What am I hoping for in this column with the sum? Yeah, we want that negative 23x. As soon as we find that one, we win. And in fact, if you don't feel like doing the arithmetic, you can just skip over ones that are clearly not negative 23x, right? 2 minus 54 is not anywhere close. You can write it if you want, but you don't need to. You just need to find the one that works. You see it? Or negative 27. That gives you a negative 23x. That's the winner. Again, I think that's the toughest part. Listing the factors until you find the winner. Questions on how to list the factors? Yerka. I'm not going to make you use the box. No, I mean, the question is just going to say factor it. And as long as you get to the right answer, even if you don't show any work, you'll get full credit for it. But you got to make sure you've got some process that is 100% accurate, because if you get the wrong answer with no work, you're getting no credit. Okay, so the first method is trial and error. And in fact, that's how I did this when I was in your shoes, is I just did trial and error, and I would just run through all of them until I found the winner. Now, it turned out I was pretty quick at foiling, so it wasn't that big a deal, but that was my method. This box method I never ended up using as a student. There's something called factoring by grouping, which is another technique, it's the same amount of work, but it's just a different way of organizing things. I'm not going to cover it in class, but if you are interested in alternatives, you can see me outside of class. And then there's something that I learned over at Deerfield Academy, which they call funky factoring. Personally, that's what I end up using. Like, I think that's my favorite way to do it. Again, it's no more or less work. It's just a different way of organizing stuff. But if you want to see, I can give you at least 2 other alternatives if you're not thrilled with the box. Okay, so we found our winner. It was 4x and negative 27x. Quick question. What if we're making this list and we get plus 23x? We wanted minus 23x, but we got plus. You change the signs. It doesn't mean you got to keep going and find a million more factors. If we got plus 23x, then what would the answer be over here that would give us the right thing? Negative 4x plus 27x, okay? So you can save yourself some time by knowing that if you get the right number but the wrong sign, you have the winners. You just need to change their signs. Okay, so we've got the winners, 4x and minus 27x. So again, it makes no difference where you want to put them. I'm going to put them here, and if you feel like having something that looks exactly like the board, then put them in those spots. Okay, and let's give you guys a minute with your neighbors to look in each row and each column, pull out the biggest thing you can. And this is the first one where we have to worry about positives and negatives. So leave them off, and if you remember how to handle it, then put them in, but otherwise we'll talk about it in a minute. All right, so before we talk about signs, any questions on what I've pulled out? Okay, and then to figure out pluses and minuses, Victor read that rule to us. To decide what the sign is, you just have to look at the first entry in the row or the column. So in the first row, the first thing you see is the positive 18, which means that's positive 9. In the second row, what's the first thing you see? Is positive 4x, so that's really a positive 2. So I really do need to put that sign in. So this is a positive 2. In the first column, what's the first thing you see? Positive 18, so it really is positive 2. In the second column, what's the first thing we see? Negative 27. That one must be negative 3. Okay, so putting it all together, we just have to read 2x minus 3, 9x plus 2. We've got our answer. All right, so I freely admit there are a lot of steps to this process. But a lot of steps shouldn't be intimidating. As long as you can do each of the steps and you know what the steps are, you can do the problem, right? So a lot of steps means the problem will take you maybe longer than the normal algebra problem, but it doesn't mean it's hard. Questions on any of the steps? Yeah, Victor. Yes. We multiply them. Yeah. In fact, we never really even talked about why this magic thing worked. Do you guys remember what we discovered about the product of the things on the two diagonals? They're the same. We did the product and we got the same thing both times. Well, guess what? That's why this works. We looked at the product of 18x squared and negative 6, and that gave us this minus 108. We know that the product of the other diagonals, even before we fill them in, the product of the other diagonal must be minus 108x squared, right? So then what did we do? We factored minus 108x squared. We just listed all the things that could give you a minus 108x squared. One of these things in the list has to be in the blank spaces in that other diagonal. Those are the only things that give you minus 108x squared from the first diagonal. And we just are after the one that adds up to that middle term. Okay, so on the very next page, you're going to see maybe a new phrase, completely factor. So as if this procedure weren't long enough, sometimes you have to do two different kinds of factoring in the same problem. But the good news is that the first thing to do It's right here. It says when factoring, always factor out the greatest common factor of all terms first. Always, always, always. Golden rule, any problem that you see in the homework or on a quest or on a test or on the final, if it says factor, your first thing to look for is the biggest thing that goes into both. The first thing to look for is not difference of two squares, which is what we started with today. It's not product sum. It's not the box method. It's not anything other than, is there something that goes into all those terms? And if so, let's pull it out into the front. So looking at this trinomial, first of all, I'm very intimidated because the first power of x is 4. But everything we've been doing for the last 2 classes has been x squared, right? So already I don't know what's going on with the x to the 4th. Also, pretending it's x squared and x and a constant. Is this an easy product sum or the harder box? Is it easier or harder? How do we know? If it was this, 10x squared minus 50x plus 60. Getting rid of that. How do I know if it's the easy product sum from last class or the harder box today? It's that guy right there, right? Everyone we did last class started with what? Just plain x squared. But the ones we did today wasn't plain x squared. It was 3x squared or 6x squared or 10x squared. So my first reaction is, gosh, I don't know what to do. It's x to the 4th, and oh goodness, it's a hard one because it's a 10 in the front. But let's follow the advice here. It says factor out the greatest common factor. Looking at the 10, the 50, and the 60. What's the biggest number you can take out of all 3? 10. So we're going to put a 10 outside, and then we're going to figure out what goes inside. But before we do that, there's actually x's in all 3 of these terms. And you want to pull out as many x's as you can, but you got to pull out the smallest number of x's you find anywhere. What's the smallest number of x's? Is x squared. And do you buy that maybe, just maybe, this original came from somebody taking 10x squared and distributing it into 3 terms? Because there's a 10x squared in all 3 of those guys. So we just got to figure out what they used to be. So 10x squared times something is supposed to give me 10x to the 4th. What's the something? It's x squared. That's what it is. 10x squared times something is supposed to give me this 10x to the 4th. The right answer is x squared. Now, if you can't just have that miracle by looking at it, here's one thing you can do. You can take this guy, 10x to the 4th, and you can divide it by this guy, 10x squared. What happens with the 10s? Cancel. How many x's are left when you cancel? X squared, which is what goes right there. We'll do the next one the miracle way and then the procedure way. This 10x squared times the next term, whatever the next term is supposed to be, needs to give you minus 50x cubed. How are we going to get the minus 50? It's with a minus 5. I need x cubed. I have only x squared right now. There must be another x in play. But if you can't see that without writing it down, no problem. All we do is we take this guy, negative 50 x cubed, divided by this guy. It's always divided by the thing that's in the front. See how on the bottom of both fractions it's 10x squared? All you're doing is you're saying 10x squared was in the front. We just take it out of both things. And when we reduce, minus 5, that goes right down here. Oh, minus 5x, which goes right there. Yeah, Megan. It is time to go. Yeah. Last term is a plus 6, which is the 60x squared divided by the 10x squared, plus 6. So that's factoring out the biggest thing you can from all of them. And there's still a tiny bit left to do, but it's actually pretty easy, and we're out of time, so we'll end. But you still need to do the thing in the parentheses. X squared minus 5x plus 6. Is that the easy product sum, or is that the hard box? It's easy because it's just x squared. Okay. Yes, you do. So I'll write the final answer here. You can check later. The 10x squared isn't going anywhere. Do the product sum business from last time, x minus 2, x minus 3, and that's it. Okay, sorry for going over. Have a wonderful weekend. Again, this box stuff is not on the quest, so focus your energies on studying for the quest. Do the box homework Monday night.